So this is lesson 1.2, which is about the organisation of the course and the structure of theoretical history as a discipline. And this is an introduction, so the aim is to give you an overview of everything that is done in theoretical history. And I've taken a very broad view as to what to include because I'm interested in ideas, and ideas don't have to be 100% correct for them to be interesting. And even if ideas are wrong, they may stimulate us to develop better ideas. So I divide theoretical history into 6 areas which will correspond to 6 modules of the course. And the first one is cultures and civilizations. So we know that there are different civilizations: the Egyptian civilization, the Chinese civilization, the Aztec civilization. We know that these exist and that they're different from each other. And in this module, we'll be concerned about the theories as to how these civilizations come into existence and what explains their different ideologies, their different world outlooks, and also how civilizations develop over time and maybe come to an end, and the relationships between civilizations. Anything to do with that will be covered in that module. Then the next area I call social evolution and progress. And in this we'll be concerned with the phenomenon of economic growth over history and the laws of economic behaviour, and related to economic growth, the growth of world population and the growth of technology, which are deeply related to economic growth, and also the processes of innovation, what causes innovation and how do innovations spread from a point of origin to the rest of the world. So all those theories will be there. Then the next area is political evolution. So we know that in earliest times people lived in family level bands, whereas today we live in complex states with governments and formal systems of taxation and law enforcement mechanisms. And the question is here, how did we go from one to the other? So we'll be interested in the different forms of political organisation that have occurred through history, and in things like the rise and fall of empires, which are an advanced form of political organisation. And as well as the politics that takes place within countries, we'll also be interested in the politics between countries, so in world systems, international relations. And we can say with these 3 areas then we're covering the main areas of social life. So this is the social or socio-cultural side of life. This is the economic side of life, and this is the political, of course. So we've covered those 3 main areas: social, economic and political. And then the next module, the next area of theoretical history, is urban systems. So here we're interested in cities and systems of cities. And there's now a whole discipline grown up around urban systems, and we'll be drawing very much on that literature. And this combines some of the ideas from the earlier modules. So cities are have a political aspect because they have local government, for example, and they have an economic aspect because they're centres of economic activity. And it's helpful to bring those different ideas together into one area, specifically on cities. And so we're interested in the way cities are distributed in the landscape. We're interested in the relationship between the population sizes of cities and their economic output and their output of innovation, and also in things like crime, how the populations of cities are related to the incidence of crime. Then the next area is cycles. So many theories in theoretical history have to do with cyclical behaviour. So there's the rise and fall of empires, or there's boom and bust in the economy, or there may be cyclical variation in the attitudes of generations from father to son to grandson. And it's helpful to bring those all together into one area because they have similar problems that they present and similar techniques to understand them. And then lastly, we'll be concerned with environment. So in these earlier areas, earlier modules, we're interested really in the interactions between people, the relationships between people. But with the environment, we're concerned with external factors that affect social change. So a big one is climate. How does climate affect historical processes? Geography is another. Whether a society is on the coast or inland, how does that affect its historical experience? And disease is another one. Disease can be seen as a kind of external shock, and how does that affect historical change? And I think lastly, resources. So some parts of the earth have more resources, like Saudi Arabia has a lot of oil, and others have less or different. And the question is, how does that affect historical interactions between societies and the development of those societies that have easier access to resources? And then underpinning all this, there is mathematics, mathematical methods. And we will spend some time thinking about mathematical methods. And in the book, I do assume a certain level of mathematical competence. In these lectures, I'll talk through things a little more gently and fill in some of the details. And not everything is mathematical, but certainly quite a lot is. And I'll want to give you an example of why it's worth us thinking mathematically about these things. So here is a chart of the number of people who had been in space, the cumulative number of people in space from the 1960s to the 2020s. And if we plot that, it looks something like this. There was an acceleration and then it kind of tailed off. And we find that we can actually plot a very precise mathematical curve through those points, a curve that's known as a logistic. And a logistic curve arises from a very well-known equation, which in its simplest form looks like that. Now, no need at this stage to worry about what that means precisely. We'll be covering this in a lot more detail later on. But just to know that there is an equation that exists. And in this case, x would be the number of people in space. So having seen that this is a logistic, we know that there is this equation that governs it. And we can start to ask ourselves, why would the number of people in space obey that equation? And by asking ourselves that, we can then start to understand the processes that are operating to create this particular pattern. And so we understand the historical processes that are driving this innovation process of the exploration of space. And what's more, we find this same logistic curve in a whole range of other processes to do with innovation and discovery. The spread of a new technology, for example, often looks like that. And the processes of the European exploration of the world, the discovery by Europeans of different parts of the world, also went in these logistic pulses. And what's more, when we find this logistic curve in other areas, it's also typically about 50 or 60 years long, the pulse, which it is here. So, we can say, yes, that's another 50, 60-year logistic, as we typically see in processes of discovery. And then there's a theory as to why it might be 50, 60 years, which is that it represents 2 human generations, with a generation being about 25 to 30 years long. And to understand that, think about over the next few decades, a number of countries on Earth are planning to exploit the moon. And as they do that, exploit the resources of the moon, and as they do that, they're going to want geologists to roam over the lunar surface and find where the minerals are, so they know where to build the mines. And as they do that, as they discover more and more mines, they're going to want to be able to exploit them. Now, so they're going to need miners. You don't get miners by taking, crusty old geologists who spent 20, 30 years doing the geology of the moon and then retraining them as miners. You recruit people coming up from below, people coming into the workforce. And what will happen is that in the schools and universities, the careers advisors will be saying to the students, don't go into geology. That's demand's falling for geologists. It's miners that they want. So go into mining. That's where the real money is now going to be made. And so they'll get more and more miners coming up. And as they do that, then they'll be exploiting all these mines that they've discovered. And eventually they'll be exhausting those mines. And they'll be getting to the stage where they need more geologists. And so now the careers advisors will be telling their students, don't go into mining. Geology is what they're looking for. Get into geology. And so you can see how there's going to be this 2-generation swing from initially everything's into geology and it'll be taking off geology, but then that is the demand for geologists is petering out and it's miners coming in. And then it swings back to geologists. So it takes 50, 60 years to swing from one to the other. That is a theory as to why this occurs, and it applies not just to this, but to all sorts of innovation and discovery processes. And now we understand that, we can possibly say, well, what should we expect over the next 50, 60 years? We should expect another logistic. But this one will probably be on a lot bigger scale, whereas this one ended with, hundreds of people having been in space. This will be millions of people having been in space by the end. But we do know that it will follow this pattern of an acceleration and then a plateauing, and furthermore that we would expect it to last another 50, 60 years again.
And that's a useful thing to know if you are thinking of investing in lunar mining stocks.
So that is why it is worth thinking about mathematics, so that we can recognize patterns when we see them, we know what they are, and we know what causes them, and so we've already got a feel for what processes might explain them, and also so that we can compare them or see them as part of more bigger abstract principles, that this is not just about space, but this is about innovation and discovery processes in general. And then before all that, before we get into that, I want to just spend a little time talking about some general ground rules for the course. So one aspect is that when we talk about history in this course, we'll be talking about the last 50,000 years. So it's longer than history in the strict sense, where it involves documents and writing. We're also considering things that we only know about from archaeology, but we're only going back 50,000 years. We're not going back to pre-human hominids. We're not going back to the Big Bang and the beginnings of the universe. We're interested in human history or human experience for the last 50,000 years. So that's one issue, and I'll go into this in more detail to explain why I picked 50,000 years in that. And then there's a range of other background issues that we need to cover. So the structure of the course then will be, this is module 2, that will be module 3. And, you know, I'm keen to get on to the real meat of the course, the theories of history, not spend time on mathematics. And certainly I won't be just investigating mathematics for its own sake, but we'll try to use lots of examples from theoretical history to make this as relevant as possible. But nevertheless, you know, it's like we do have to cover that. Then we can get on to these. So that will be modules 4, 5, 6, 7, 8, and 9.